student webinar on Specialist Mathematics Matrices Part 2. Earlier this morning we looked at Matrices Part 1 presented by Jim Lowe. I'll be looking at a couple of things including dominance matrices, Leslie matrices, and I'll mainly be using a maths box in a notes page so we can do some investigation and quick calculations without creating the screen on the calculator. I'd also like to go through how we can define a matrix quickly for repeated calculations. So most of the tools that we'll be using are in the calculator page and the notes page. So the notes page is very handy for editing and doing quick calculations. You saw earlier this morning the matrix tools in the calculator page, and a number of different tools there. You can create the matrix, you can look at the determinant, you can do the row operations, etc. And as usual in the calculator, there's lots of different ways of getting to putting in a matrix, and we'll have a look at how we can do that a lot quicker. So probably the quickest way to do this, so there are lots of steps there to get to actually putting in a matrix. So the quickest way to do this is to use the little template which is highlighted there, and you can see we've got a matrix there which can be edited and changed. Okay, so that's probably the quickest way to get there. We'll go through that in a second. We'll also want to go through defining a matrix. So there's a couple of ways you can do that too. You can be in a calculator page and select define, or another quick way of doing this, especially in exam situations, is to use the control and then the template, and this will set up your matrix as a defined matrix, so you can use it over and over again. So I'll just go through some examples now on how we can do that. First of all, I'll just insert a calculator page. So if we go here and pick a calculator, and we can define a matrix by going to the menu and clicking on Actions and Define. We call that matrix M equals, and then if we go to the template there, and I just want to make a small matrix. So if I make a 2 by 2 and just tab through to put some values in, and then hit enter, and that will show you that that's been defined. So I can look at m squared. I can look at lots of different calculations involving m. So the other way of defining a matrix, we can start off with m, and this is probably quicker. If we go control and then hit the template, we get that colon and equals, and then pick matrix that we want, and what will happen now, this will override the previous value that I had for m. Oops, I didn't put a value in there, and hit enter, so that's now defined as well. Okay, so I'll just go back to my original topic to talk about, dominance matrices. So this is an example of a round robin where A beats B, A lost to C, so the arrow's going the other way there, and A also lost to D. So this is a directed graph or a digraph, so we can develop a matrix for this. So there's the actual matrix there. So if we look at that matrix, so A beats B, so there's a 1 there. A loses to C, so there's a 0 there, and A loses to D because the arrow is going the other way. And if we keep on filling out the rows, so B lost to A, so that's a 0, B didn't play itself. B beat C, so that's a 1, and B lost to D. So that's a one-step dominance matrix. And we can add up the rows. So if we add up A's row, that totals 1, B's row totals 1, C's row totals 2, and D's row totals 2 as well. So it looks as though C and D are equal in the competition. So we can set up a two-step dominance matrix and have a look at that, and we can add them together and total the rows and see who ended up best overall. But what does a two-step dominance matrix look like? Well, I might just put it down here on a notes page. We can put in a maths box here, so Control M, so we get this little box, and I'm going to put in the one-step dominance matrix, so I'm going to call that D, and I'm going to define that and go to my matrix template, and it's a 4x4, and let's just put these values in, so 0, 1, 0, 0, and just tab through 0, and then 1, 1, and 1. Now just make sure you don't jump out. If you jump out of the box like that, it won't actually define it. So you need to be in the box with the red dotted outline. So when I hit enter, you'll see that that matrix is defined there. So let's have a look at what does a two-step dominance matrix mean. So I'll do that in a second, but I've got the two-step dominance matrix up here. So if you look at C, there's a 2 in for C, so C can get to B in two ways. So if we follow my mouse, so C beat D and D beat B, so that's one way, and the other way is C beat A and A beat B. So that's how we get that 2 in there. So for a one-step dominance, for the 1 in from C to A, we've got C beat D and D beat A. So that's what that 1 means there. So I can just check down here. Raise that to the power of 2, and there's our two-step dominance. So now if we go back to the question, which was look at D squared plus D. So we want to add up that. So let's use a math box again. So when you hit enter, this math box will just automatically appear. And I can do that. Now, if we add up the rows, so you can see A has a total of 2, B has a total of 3, C has a total of 5, and D has a total of 4. So we can also add another matrix in here, a column vector. So we can multiply by our matrix, D plus D squared, and it will total the rows for us. So if we put in a column vector, I'm going to call it E, and we define that, and we just need a column of 1s. So it's a 4 by 1. So if I put in 1, okay, hit enter. So that's now defined as well. So I can quickly total my D plus D squared by . . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . putting that in brackets and multiplying by E. Okay, so there's my ranking. So once again, you can see that C is the overall winner on 5 points, followed by D, B, then A. Now, the next question, using this weighting, so a one-step dominance plus half a two-step dominance plus 1/4 of a three-step dominance to rank the teams A, B, and C. Well, we'll do this, but first of all, is it valid to invoke three-step dominance? So let's have a look at how the ranking works out. So because my matrices are all defined, I just need to insert a math box, and you can see that matrix is defined because it's come up as a dark D. 0.25, oops. And D cubed, I think that's right. So remember, don't jump outside the box. If you jump outside the box, it won't do anything. So you need to be inside the box with the red dotted line. And if I hit enter now, so you can see there's my matrix, and I needed to actually multiply it by my column vector as well. So I might just copy all that. And I'll just put that in brackets. Okay, so we end up with still the same ranking, but let's now have a look at what D cubed actually looks like. Is it valid to use a three-step dominance? So what actually happens if you look across the diagonal here, the leading diagonal, so there's there's one way of a three-step dominance from A to A. If we go back and have a look at how thinking of a three-step dominance, so we can have A beats B, who beats C, who beats A. So A is actually losing there. So using the three-step dominance is not valid in this case because of A losing when we're looking at winning teams. Okay, so just one thing there, we can quickly edit these math boxes too. So you can do, so for example, if I change that back to a 2, probably not valid, but you can see there's the ranking there. So C still wins. So as an investigation, it could be looking at a valid ranking system whereby it's fair and just to all teams involved. Okay, so moving right along onto the Leslie matrix model, and this is used to model population from one time interval to another, and we basically just need the birth rate for each age group and the survival rate for that age group as well. Sometimes the data is given as a death rate for each age group, so we need to subtract that from 1. So here's an example. This animal population has a life expectancy of 20 years, and we've got the initial female population, and in the end, to get the total population, we just assume that the number of males and females are equal, so we just double that. And each interval is 5 years, so we can set that up as a matrix. Oh, I didn't mention the death rate. We need to go 1 minus 0.5 to give 0.5, 1 minus 0.2 to give 0.8, etc. Now when we set up the Leslie matrix model, basically the birth rate goes across the top here and the death rate goes down on this diagonal from the second row to the bottom row. And we can model the population after n intervals. Let's just now look at setting that up in a notes page. So we've got math box we want to use. So Control M, and I'll call this L, Leslie matrix, and we want to define that. And we want to put in a matrix, and this is a 4 by 4. And let's put the values in. Two, 1, okay, 0.5. Now this population, because the birth rates are less than 1, this population is on the way out. And we can investigate how long that will take and see what happens to the population. Okay, so that's defined. And then we need our initial population, so I'll call that P, and we want to define that and choose a matrix, and this is a 4 by 1, and we put in 30, 24, 15 and 8, and we also need a row vector. If we get a row vector, this will sum up all the population groups for us to get the total. So we'll define a row vector, and this time we consists of one row with 4 ones. And oops, didn't get the one in. And oops, and I jumped out. Remember, don't jump out of the red dots, otherwise it won't be defined. Okay, now, so we've got our Leslie matrix and initial population defined. So we can now look at question here, and I'm in a notes page, so all I have to do is Control M to get a math box, and we want to see what the population is after 10 years. Now, because the age group goes up in groups of 5 years, so that will be 2 time intervals. So for our model, how it will be 2. So I'm going to put the row vector first. So if we do E times the Leslie matrix to the power of 2 times P, that should give us our population. So the female population after 10 years is about 44. Okay. Now, the next question I've got is how long will it take for the population to die out? So I'll just go back to that. So what we can do now, we can just play around with this and edit So if I change that to a 4, you can see they're down to 14, double that, they're about 28 in number. I try 6, I'm down to 5, double that, about 10. If I try 8, there's 2 females left. 9, so there's 1 female left, and double that, 1 male. So, oops, let's go to 10. So after 10 lots of 5 years, so after 50 years, the population has died out. Okay. Now, we can get the long-term decay rate. So if we look at a value, so we said 10 years, so to work out the long-term growth rate, so E times L the 10 times P, so that number was 0.8, and if I did the previous year, E, now it doesn't actually work when you put this in a fraction template, so that's why I'm doing it separately. If I do the 9th times P, so I get 1.33. So now I can work out what the decay rate is for the population. So oops, I jumped out of that, sorry, and I forgot to -1. Okay, so my decimal disappeared there. Okay. So yeah, it's about, I've got that round the wrong way, have I? Yeah, so it should be around the other way, sorry. Okay, let's just go to the next one. Oh, so here's another population one. The lifespan, or the rat population, they live for 3 years, and here we have some birth rates that are promising, so this population will increase. So let's model that. How long will it take before the population gets over 1,000? So if I insert a math box again, and call this L again, and this will override the previous value that I had in for L, and this time it's 3 by 3, so 1.2, 2.1, 0, 0.4, 0, 0, 0.2, 0. That's defined. And then the initial population, so using a math box again, Control M, or if I just hit enter, that will come up anyway. I'll call that P, and we need 3 by 1, so 10, 6, and 4. Hit enter, that's defined, and we can use another row vector, call that E to do the total for us. And That's 1 by 3. Okay, so that's now all set up, so we can look at, we want to work out when the total gets to 1,000, past 1,000, the female population is past 1,000 for the first time, so times L to the 5 times P, so the total, oops, P, what do I do? Sorry about that. Oops, I've done something wrong there. Okay, I've got that defined. Oh, I didn't define E, so I jumped out of the box there, and E is not defined. So E is now defined, and that fixes that up. Okay. So after 5 intervals of 3 years, the population is 238. Let's just put in a 9 there. So after 9 years, sorry, 9 lots of 3, 27 years, that's the population. We just want to get over that, so we'll just check. After 8 lots of 20, yep, 8 lots of 3, 24 years, that's the population. Just check what 7 gives. Yep, so the answer is 8. Now, jumped out of the box again. To get the growth rate, I'll just quickly finish up on this, so I'm running out of time. So to get the growth rate, E times L is 7. Oops. Times P. So if we look at that ratio and subtract 1, we'll get this should be getting close to the long-term growth rate. They do stabilise fairly quickly. 6, 3, 5, subtract 1. Okay, so that's the growth rate. It's about 72%, and we can edit this, put in 100, a massive number there. If we do 99 there, we can look at that ratio, and that should be 14.4 divided by 0.72, so it should be around 70%. No, it's stabilised. I've done something wrong there again too. Okay. Finally, the last thing, you can work out the culling factor. What value of H should you harvest each year so that you get a stable growth rate? I do there. Sorry, I did something wrong there. Oh, 1.4, sorry. It's 1.4. I got 8. Sorry. There's a 0.5. Better. So yeah, about 70% when we take away 1, well 69, so that's population, the growth rate is about 70%. So on that note, I'd like to finish there. So just remember, with a math box and a note page, you can quickly edit and change things. So very handy for an exam. So don't forget, if you would like copies of the webinar and work problems, they're on the student website. And that's all from me. Thank you for listening.